Jeffrey. Good evening.
Hi, John. Good evening. Sorry, I just forget to send you the link.
No problem. You're fine. No worries.
Okay. So, you ready now?
Yeah, I'm just clicking
Yeah.
through.
Yeah. Yeah, you're just coming into the class.
Yeah.
So, how's your class going?
I think it's going pretty well.
Mm-hmm.
I kind of felt like, well, one thing is I'm a little bit behind on my homework. Like I didn't finish all of chapter 2 stuff, but I got maybe halfway through it, but I have so much work in this semester with all my other classes that I'm trying to
Mm-hmm.
still balance it all. But I'm thinking I think I have enough time to catch up because this Thursday in class he's gonna go over all the homework problems. He's not gonna
Okay.
introduce anything new, and then the following Thursday I'll have my exam on these first 3 chapters. But
Okay. So, let's start. Problem number you gave me like
yep,
3.3, am I right?
yeah, 3.3. I got the book open on my
Let me have,
on my computer here. It's just assigning UPAC names for alcohols.
mhm. I will open the questions 3.3. Hold on just a minute.
Mm-hmm.
Okay, 3.3. Okay, 3.3. Assign IUPC names, am I right?
Yes.
To the following alcohols. Okay, let's start with the first one, A part of this question. I want you to give I'm going to explain something and then you will give the name.
Okay.
For example, for any alcohols, and I'm going to follow your method, your book's method.
Okay.
So alcohols, because alcohols has OH group with radical. Sorry, OH group attached with radical. Radical may be methyl, ethyl, propyl, anyone. And the name of the alcohol according to IUPAC system is, we take the alkene name depending on the number of carbon atom, main chain, remove the E and we add OL. So it becomes alkanol.
Okay.
Alkanol. And the number is, for example, if it is butanol, so I'm going to say where the OH group is there. If the OH group is at 2, so I'm going to say 2-butanol. Or you can also say that according to nowadays, just write butane and then 2-ol. Butane 2. So both of them, this is in your book, I think. So
Okay.
2-butanol. So now try the first one by yourself.
Okay. So we have CH3, CH2. It looks like a propyl group with a OH on it.
Hmm.
So I'm thinking propanol. Is that it?
Propanol, you're right. But what propanol? Because OH can be at 1, can be
One.
at 2,
One propanol.
1-propanol. So the name is going to be 1-propanol.
Okay.
That's the name. Now suppose if I am giving you this one, and also important thing is you give the preference in numbering to the function group, to the OH group, not to the radicals, not to the halogens. For example, I am writing this one, CH3, CH, CH3, CH3, H, and I'm giving you CH2, CH2OH. So what will the name, what we predict the name of this compound?
We got one.
First, always select the main chain. Yes, you're right.
Yeah, so this would be, let's see, 1, 2, 3, 4, 5. It should be 1 pentanol.
But that's the main name.
Right.
But
So it'd be 3, comma,
mm,
4
mm,
dimethyl,
very good.
and let's see, dimethyl, and then dash 1 pentanol.
Normally,
No.
look your book, but nowadays we don't put the dash. Okay, but double check your book answers because nowadays they don't put dash.
Mm-hmm.
They just put continuously like 1, 2, 3, 4, 5 pentane and then put 2 ol. But depending on your book, maybe dash. Just check your book. Okay, in the solution. What is the answer there? How they are writing? They are putting dash or something.
Well, this was your example. I'm just trying to find if there's a comparable one where it has.
Okay, we can later see that one.
Multiple.
Okay, don't worry.
Yeah.
Look this one, the C part, 3.3 C part. I want to check that one because how they are writing, it will be clear there.
Okay. All right, 3.3C. They're naming it as 2-chloro, 3-methyl, 1-butanol.
2-chloro, 3-methyl, 1. How they are writing? 3-chloro.
No. It's 2-chloro.
Oh, sorry, 2-chloro. 2-chloro.
Yep.
And then dash 3-methyl.
Yep. Dash 3, dash methyl, dash 1, dash butanol.
Dash 1-butanol. Am I right?
Mm-hmm.
Okay, well, I'm going to follow this thing. This one. Okay. Because nowadays they don't write dash. That's fine. Okay, it's better we follow the book because your teacher is going to doing like this.
Mm-hmm.
So, okay, now let's see the B part. Now for B part, I'm giving you some hint and you are going to try it. This C6H5, this radical is called phenyl radical. Just like methyl, ethyl, propyl, we call it phenyl. And phenyl means like a benzene ring radical. So you can also write like this, benzene radical, like this is phenyl. And now it is attached with CH2, 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 OH. So what is your main chain in this case?
Oh, so this is B, right? Okay. So the main chain, I was thinking, since OH is on the
Can you just make a rectangle there? Yes, you're right. This is your main chain.
Okay.
And now start numbering from which side?
Right here. 1,
2,
2, 3.
Yes.
Right? So it would be 3-phenyl, 1.
3-phenyl, you're right.
Yep. And then
3-phenyl.
And then 1 propanol.
1 propanol, you're right. And check your answer there. It's going to be this.
Just grabbing it. Yes, 3-phenyl, 1 propanol.
Okay, and also I will recommend that when you are giving the numbering, put the numbering at the top so it will not mix up with the number of carbon atoms.
Okay.
Okay, so that's good. Now let's, we already did the 3C part, 3,4-dimethyl, oh sorry, 2-chloro, that one. Now let's do the D part.
Okay. Yeah, this
D
one
part.
looks like it's It's got two OHs to it. So let's
Yeah,
say
there
one,
is.
two,
Okay, I'm
three,
going to
four.
give you some hints and then you will get the name depending on your book's naming.
Mm-hmm.
CH2. How many carbons are in the ring, in the main chain?
4.
4. Now the old method was, which your book is using, because it doesn't matter from where we give the number.
Right. Left or
So
right.
it's 1, 2, 3, 4. And I can say like this, it's a butane things. But we have 2 OH. So I'm writing like 1 and 4, 1 comma 4. And then writing butane. Some books write the up to the E and then write diol. Some writes without E. So just check what your book is using.
They're
Of
doing
course,
1,4 dash butane diol. Butane diol. It's
are they using E or without E?
E. E, and there's no dash.
Or no dash. So they are using without dash.
Yeah, it's really strange.
Okay, so use that one. Because different, they are not going to
really
take a
strange.
point. Normally we give that, but they have to give the dash actually. Okay, it's clear this one?
Yes. Yep.
You can ask teacher because it's better to give the dash. I don't know why they are not giving.
Yeah, this book is like from 2013, I think. It's like,
Yeah, that's why
it's
they
like
are
7
old.
years old. I don't know why they're still using it, and it's crazy too because for those general chemistry courses, they're using that book from they're using that 7th edition.
Yeah.
Remember?
So no problems. This is even if you will write the correct name to your teacher is not going to take point.
Yeah.
Okay, now let's go to the E part.
Okay.
And what you think about this E part?
All right. This
First
one.
think by yourself.
This one is telling me that it's a phenol because it's got. No,
it's not a phenol.
it's not phenol. It's the main chain would be the cyclopentane, wouldn't it?
Very good. That's
Okay.
right.
Okay. So if, let's see. If it's cyclopentane, the carbon one is is where the hydroxyl group is.
You are right. Carbon 1 is this. Okay, that's right. Now what do you think too?
Alphabetically, chloro
Yes,
would be
yes,
two,
you're right.
right?
Alphabetically, go by alphabetically.
Okay.
Because radicals and halogens are same type of thing you can consider. So now what?
So we would have 2 chloro dash 5 ethyl, and then
2 chloro dash 5 ethyl.
and
Then
I'm thinking, would it be all one word? Ethyl cyclo.
because your book is using dash, so I'm putting dash. Okay.
Yep.
Normally we don't put the dash in the new method.
I just looked at the I don't know.
And I'm going to put now. Look here. I'm not going to put 1 because there is only one OH and definitely it's going to be 1. So I'm going to put like cyclopentanol. Cyclopentanol. Just check either your book is putting dash or not.
No dash.
No dash. Okay, so just write together. It's better without dash. So just combine them. Okay. So, and they are not putting any number. Am I right?
No number.
Yeah, because there is no other possibility. Because definitely we are going to, in cyclic case, the 1 is going to be with that carbon which has OH group. Okay.
Yes, sir.
Now let's go to the. I'm asking another question from here.
Okay.
Same thing, but little bit modifying this question. Which writing C2H5 ethyl group, writing Cl group. Now what name you are going to give this about this?
All right, we have cyclopentane with the OH, so that's going to be cyclopentanol, but
Yes.
we have chloro, and then we have C2H5, so that's
Mm.
phenyl, right?
No.
No, not phenyl.
C2H5 is ethyl.
Ethyl.
Instead of writing in that way, I just combine them together.
Oh wow. Okay.
C6H5 is
Mm-hmm.
phenyl.
Mm-hmm. Okay. Ethyl, right?
Can you give the number?
If this is 1,
Mm.
wouldn't this be 2, 3?
No, because now if you are going counterclockwise, your first group appears at 3
Mm-hmm.
after OH because OH is at 1.
Mm-hmm.
But if you go clockwise,
Mm-hmm.
the first group is going to be nearer, like at second position.
Yep.
So forget about alphabetical in this case. We
Really?
are
Okay.
following the alphabetical when the number is not changed. Either we go 2 is here or 2 there.
Thank you for specifying that. Okay.
That's why I changed and modified this thing. So you will not follow always the alphabetical. It's clear?
Okay. Yeah, we want to go to the nearest branch in that case?
Yes. In that
Okay.
case, we followed alphabetical because if I go by this, it's still 2. If I go by this, another will be at 2.
Yep.
So the position is not changing, 2. So that's why we prefer alphabetical also. Okay?
Yep, very good.
Okay, now let's go to next one. We did EF.
Yeah, F. So this one it's got cyclohexane, and it's got 3 OHs on it.
Yes, cyclohexane ring.
Alright, so if it were 1, 2, 4, 1, 3, 4. So I'm thinking the numbering is 1, 2, 4. So,
You're right.
So would this be? This would be. Let's see. 1, 2, 4.
Okay, 1, 2, 4. What do you think?
Cyclohexatriol.
Cyclohexa, the cyclohexene, tri. I prefer, but double check the answer because I prefer dash always. Even because in the old system we have to write the dash there.
Oh yeah, there's no dash. It says 124-cyclohexane triol.
It's a cyclohexane full name, am I right?
Mm-hmm. Yep.
Okay. Ask your teacher because even in the old system, old books, I know that this dash was there. I don't know why they don't. Ask if I put dash is okay or not.
Okay. Yeah, I'm gonna.
When your teacher is doing in the class, how he writes?
He writes it without a dash.
Without a dash. Okay,
Yeah,
then do it without dash. Okay, now what next? Question number what?
Let me see. So next was 3.7. It says draw structural formulas for each of the following. And,
okay, in this case, when you are drawing the structure formulas, first make the main chain. Don't put that like some space for hydrogen. We will fill the hydrogen later. And just look, what is 1-butanol means? How many carbons?
4.
4. So what we have to do first?
All right, so I'll do
Yes, very good. So first thing is do this one, the last part.
Okay.
And 1-butanol means what? Where is the OH? Now, because you are giving the number, you can decide from where the which one is the one.
Okay.
Okay, that's good.
So it'll be
And what
there.
other groups are there?
2-methyl.
2-methyl.
Be
So just put 2-methyl. Up and down doesn't matter. And now fill the hydrogen and line. Make the bond. That's good. Very good.
okay. Yep.
Now do the B
So
part.
that's
This was
that was it there. Okay. B. We have 2-bromo.
3.7A.
All right.
Let's do the B part.
All right.
Why you are doing like this?
Oh, I was just looking at C. I'm sorry. I was looking at the wrong one. All right. Pentanol.
Hmm.
All right. So we have 3-pentanol. So 1, 2, 3.
Okay.
And then 3-methyl. And 2-bromo.
And now just fill the hydrogen in the line.
Yeah, I think that's
That's
good.
good.
Good. All right.
Excellent. Now try the C.
All right. So we have cyclopentanol.
You don't have to write the carbon in there.
Oh, you're right. Okay.
You can just make 5
Yep.
like a, yeah, you don't need to put the carbon. Even you don't need to put the hydrogen.
Okay.
That's it. This is cyclopentane.
All right. And then it's
And
1-methyl cyclopentanol. Okay. Okay. 1, 2. So it's gonna be like this, and then like that.
very good. So both OH and CH3 are on the same carbon. That's it. You don't have to put hydrogen.
Excellent.
Okay.
Yes.
Now what next question?
It says 3.9. Name each of the following as a derivative of phenol. And it
Okay.
says 3.9A and then B.
Derivative of phenol means you have to, main name is going to be phenol. And you know the phenol means what? Benzene ring with
OH.
directly attached OH. Directly, remember. 3.9. I'm going to first explain this thing, then you will give the name. For example, this one is phenol. Benzene ring directly attached. It doesn't matter where.
Okay.
If I write like this, benzene ring, and now some chain CH2 and now OH, it is not phenol.
Okay.
It is not phenol. It is alcohol. What it is? It is alcohol because it is not directly attached. This is phenol. Of course, that is aromatic alcohol, but it is alcohol, not that one. So let's try this one. 3.9A. Because your book is using simple thing, and normally we use simple things also here. What is this? What you are going to give the name of this one, and how you are going to give the number?
2-isopropyl
You're very good. 2-isopropyl
Is
phenol.
Is it phenol all one? I can check and see. Let's see.
2-isopropyl
Yep.
phenol. They are giving dash or directly writing that one?
Directly, no dash.
That's good.
Phenol.
At least they are doing something good here. Okay.
Yeah, I have a bad feeling if I were to go right into organic chemistry class, and if I was going by what I was doing in this book, it wouldn't be good because
No. It doesn't matter. It's very little change is there, so don't worry about it. Because when I studied also in that way and both way, so it doesn't matter to me.
Okay.
Okay, now look here in this
B.
B.
So B we have it looks like phenol, and then it'd be 2,3-dimethyl phenol.
You're right.
2,3 dash.
You're right.
Okay.
What next question?
Next he was asking 3.11.
3.11.
And I think he said to skip A because he didn't go over the MOP, like the meta.
Okay, but do it. Don't worry about it.
Okay.
Meta means, like here it is. It's not a big deal. Remember that this is phenol, am I right?
Yes. Yeah. It says draw structural formula for each of the following. A is.
So I'm writing this phenol. Meta means just the next position, adjacent, like second position. So it means it is the methyl group is there.
2.
At 2 position here. And if say meta means 2 position. No, sorry, I am wrong. Sorry, I am wrong. Ortho means O means 2 position. Meta means 3 position. Para means 4 position. Like ortho means like a adjacent, just neighbor. And next to the neighbor is meta. It doesn't matter left from clockwise or counterclockwise. And para is just opposite. So in this case, the meta means it is here.
Oh, wow. Okay.
So that's not big deal. Okay, now next is 2,3-dichlorophenol. So let me make the structure and then you will put the things. First I am making phenol.
Yep.
Here they are saying 2,3-dichlorophenol. You're right.
Good to go.
Yes,
Awesome.
very good.
Thank you.
What next?
Next, we got 3.15. It says classify the following alcohols as primary, secondary, or tertiary.
3 point. Okay, I'm going to first explain this thing, and then you are going to do this thing. Okay.
Yeah. He was explaining it in class, and all the students.
3.15. You are saying.
Yes, sir.
Okay, no problem. Let me explain this thing. Very simple.
Okay.
Primary alcohol means any group, primary alkyl halide or something. For example, this carbon. This carbon, if it has only one side carbon directly attached, and it has two side hydrogen. So you can say that this carbon is primary carbon. So if alcohol is OH is there, it's going to call primary alcohol. Primary. So in primary, your first important thing is going to be CH2. The OH is going to be attached with carbon which has 2 hydrogen. And only one side you are going to have carbon. But in case this is primary, and primary means we also write like 1 degree.
Yes.
Secondary means only you have one H, one hydrogen. Look, only one hydrogen is here, am I right? And the two sides you have carbon chain. This is going to be secondary. Carbon is secondary carbon, alcohol is secondary alcohol. because it is attached with the secondary carbon. Now the next one, tertiary, is without any hydrogen, no hydrogen. All side it has carbon.
Okay.
So this carbon is tertiary. And if OH is attached with this carbon, it's going to be tertiary alcohol. Is clear? Now I'm asking one thing. I am writing here CH3, 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 CH2OH. What alcohol is this? Primary, secondary, tertiary?
This would be primary.
Primary, because it is this carbon is tertiary, but OH is not attached with this. OH is attached with this carbon, which is primary, CH2. Is clear?
Yes. Yeah, that was a good one. Yep.
So now let's go to your question 3.15. A part.
Yep.
You don't have to write, you can just tell me.
Okay. Yeah, so the OH is attached to a carbon that is attached to 1, 2, 3, so it would be tertiary.
And you see that directly there is no hydrogen with that carbon,
No
right?
hydrogen.
It's
Yes.
a tertiary.
Yes.
Okay, what about the B?
B. Okay. So the carbon is attached to the hydroxide, and so it'd be primary, right?
You're right. What about C?
C. So C is there, and then 1, 2. So secondary.
Secondary, because only two side carbon and there is one hydrogen is there, not shown.
Yep.
It's clear?
Yes, sir.
Okay, what next?
We got 3.22.
3.22. Okay.
This is these are fun.
Okay. Draw the structure of the chief product formed when the following alcohols are dehydrated to alkenes.
Okay, I think I remember what he was. I'm trying to think. It says major and minor, and the major
Yes.
one is the.
Because they are not saying which one. Okay. Because we can get both products depending on what method we are using, which way base we are using. They are saying draw the cheap product formed when the following. So let me explain this thing to you.
Yep.
3.22. Because we can get both product depending on what base we are using.
Yeah.
CH3, CH,
CH2, CH3.
CH2, CH3. And the OH is attached here, am I right?
Yes, sir.
So definitely OH we have to remove from here. Now the hydrogen we have to remove either, let me write in different way. I am writing CH2 and 1H I am writing here. Similarly, I am writing 1H here. I can remove either this one or I can remove this one, water. I can remove hydrogen from the left hand side nib, or I can remove another hydrogen with OH on the right hand side.
Okay.
Normally, if we are using the small base, and for example, sodium ethoxide or something, we have to remove the hydrogen from that carbon which has less number of hydrogen, because so less number of hydrogen. Just like 2 hydrogen is there on the third carbon, am I right?
Yes, 2 is right here.
2 hydrogens. And on the 1 carbon, we have 3 hydrogen.
Yes.
So it's going to prefer to be removed from third.
This one.
And you will get, and because when you remove this thing, I'm using this one, C2H5 base. This is a base. Sodium ethoxide in ethanol. I will get, the double bond will come between 2 and 3. Between 2 and...
Oh, okay, because it's di-substituted. That's what it is.
But there is also another method, Hoffman product. If you are using a bulky base, suppose if I am using like CH3 or thrice ONA, something like this, in that case, what happens? You will get 1 butene. But generally we get this one, because most of the time we are using this one. So just check what they are giving. Both of them answer, or only one of them answer.
Okay, I'm checking. Okay, 13.22.
Hmm. 3.22.
Or yes, yes. Um,
No, I think no. We are using which one?
yeah. Well,
Yeah, yeah, that one. Okay, 3.22. So what you will get?
okay. So they're showing reactant and product. So they gave us the reactant in the book, and then what we had to do is the product. They gave this as the product.
Yeah. So in that case, you
CH3's.
will use
Yeah.
this reactant is going to be that one.
Hmm.
Are they also giving you the reagent or not?
No, it's and
Hmm.
that's kind of strange too. But like in the
Okay, okay, because now most of the time we use this one, so it's okay. But in case, suppose if you want one butene as a major product, then we use a bulky base
bulky
because
base.
it
Okay.
is difficult for bulky to go in middle of them. So we
Okay.
just want like a easy access to that one, and that's this one. Okay, so
Got
this
it.
one is going to be 2-butene, and that's called Sazaf rule. What we call it? Sazaf. Sazaf. Just check the spelling because they are also spelled in different ways. Some write Zasaf. Zasaf rule. Just check the spelling of this one.
Okay.
So both of them are Sazaf or Zazaf, the same thing. So this is the other one when we are using the bulky base that called Hoffman product. Okay, so what next?
Hoffman product.
So it means they are using the Sazaf product.
Okay. Yeah, I was trying to look in the book to see if I could find that name in there, but I'd end up spending too much time trying to find it.
No, no, don't worry about it. Okay, now what about next? B.
B. Okay. Let's see. So I could take it from the neighbor or not. Boom, boom.
Because they are using Sazaf like a small base. So just remove.
I'm thinking. I'll write what I think is the answer for B. As the product.
In otherwise, you can say if they have too many friends, don't try to attack on them.
Yeah, I like that. That's right.
So from where you are going to remove the hydrogen?
From the right side, his right neighbor.
Because you can either remove from 1 or you can remove from 3. So from the right side, you're right
And it would
because only one hydrogen is there.
it'll give me
You don't have to fight too much with his friends.
right, right.
And double bond will be on 2 and 3. So what will the product, name of the product?
The name of this product. Let me see. 1, 2, 3, 4 carbons, and we would go from the left. So it'd be 3-methyl 2-butene.
Okay, let's see. Because here, I will write this thing.
Oh no,
Hold on.
no. It'd be 2-methyl.
Yes, because you are not disturbing the position of the double bond, but getting an additional advantage that your radical is also near there. 2-methyl
Yeah, 2-methyl 1,
butene.
2-butene. Okay.
Okay. It's clear?
Yep.
Okay.
All right.
What next question?
This is 3.23. It says draw the structures of the chief product formed.
3.23.
23.
Draw the structure of the chief product formed when the following alcohols are dehydrated to alkenes. Actually, they have to tell us what base they are using. Because if I use other base, I will get another product. Okay, but no problem. We are assuming it is the same thing, common thing. So from where you have to remove the OH, of course, you have to remove from there.
Or let's see. I was just looking at my reaction map. It says when they're going from alcohols dehydrated to alkene, they have to. They use like 180 degrees Celsius, and I think it's H2SO4. I don't know.
Yes.
Okay. So for A, let's see. Draw the structure of the chief product form.
Hmm.
All right. So there's two possibilities the where the double bond could be. So I'll draw the two structures, and then I have to decide which one is chief, right?
Hmm. So just use the H2O4 method and you will get the product data. This of product.
All right. So these are my two options, right?
Yes. So which one is going to be major product?
All right. So let me see. So out of the double bond and the carbon is there's one and then 1 2, so that's tri-substituted.
How many hydrogens were there in the when you are removing from this one? Let me I will write the original thing. Because in this case they don't show the hydrogen, you have to decide by yourself. Because definitely OH you have to remove here. Now hydrogen either you have to remove from here or from here.
Mm-hmm.
How many hydrogens are on the first situation here?
So right here, or
yeah, on the one, this one.
Okay, so this carbon right here has 2 hydrogens.
Yeah, this one has 2 hydrogens. You're right. And what about the other one, which has methyl group?
1 hydrogen.
1 hydrogen. So which one is easy for you to remove?
This one.
This
here.
one.
This
so
one
which is going to be your major product?
Less of a fight. So
this is your major product. That's right.
Okay.
The other is going to be minor.
That's not so bad.
Yeah, that's easy. It's not. Don't worry about it. It's easy.
All right.
Okay. What about the B part?
All right. B. Let's see. All right. We got CH3. Okay. We could go. This one here would give me just 1. But if we went right here, it'd be 1.
You can say like more substituted alkene is more stable.
Okay. The chief product should be. I'll write it. Let's see. CH3. Bonded to carbon, double bond, so it's going to be a
CH.
Yep.
And
then his neighbor to the right is going to lose his hydrogen because it's going to be bonded there and then bonded to a CH3.
You're right. Okay, I understand now.
Yep.
Okay, that's good. Okay, what next question?
All right, next is saying 3.25. Draw the structures of the 2 organic compounds. So 2,5. 2 organic compounds that can be obtained by oxidizing CH3, CH2. So that's 1.
Okay, okay, because 2 organic compounds that can be obtained by oxidizing this. Okay. Now remember, this is alcohol. Am I right?
Yes.
And this is what alcohol? Primary, secondary, tertiary.
Looks like it's
just
primary.
Primary. Okay. Which question you are doing?
3.25.
25. Okay. So primary alcohol. Primary alcohol. Primary alcohol is going to be oxidized to aldehyde. But if you are using, depending on what oxidizing agent you are using, it is not going to stop here. It is going to go up to the carboxylic acid. Let me have it right here. Carboxylic acid. But if you are doing something like which is not going to stop at aldehyde step, then you can also get aldehyde depending on the reagent. For example, because this in your situation, this one, it is a primary alcohol. Am I right?
Yes.
So if I write this one CH3, CH2, CH2OH, I know it is primary. If I use the common oxidizing agent, potassium dichromate, K2Cr2O7, or maybe chromium oxide, Cr2O3, something like that, chromium compound. In that case, NH2SO4 something, you will get aldehyde. Aldehyde means CH3, CH2, and this one is going to become double bond O and H. Two hydrogen is removed. One hydrogen gone from here, one hydrogen goes from here, and double bond comes between oxygen. Okay, like this. So you are getting propanol. What you are getting? Instead of propanol, it is propanol aldehyde, Al. But if I use another method, and also hold on, it's not going to stop here. It's going to further oxidize. This is oxidation happening. Further oxidize and not going to stop there. The aldehyde is going to change into carboxylic acid. C double bond O, and now another oxygen will come here, and you will get propanoic acid. Propanoic acid. This is your final product. But if I use another oxidation method, and that's commonly called PCC catalyst, in that case, it is going to stop at the aldehyde and you will get propanol. It's not going to further oxidize and you will get propanol. So you will get either this compound, propanol, or you will get propanoic acid. Check the answer. Maybe these two compounds is given there.
Okay, so the products that have it in order is propanol. They have this.
No, propanol. Propanol is the reactant.
Okay.
What is it given the name? What is there?
They don't have the name on it. They have CH3, CH2, C, and then double bond O, and then H.
This is propanol.
Propanol. No.
Yeah, not OL.
Okay.
OL is for alcohol, AL is for aldehyde, remember.
Propanol.
That's why be careful in writing O and A, because in a hurry we make like A looks like O, which is wrong.
And then they have this one.
Yes, that's a propanoic acid. So you will get both things.
Okay.
So because they are asking the name, so just write both of them. But I told you, in the first case, it's going to not stop. You will get this first, but ultimately you will get this, end up with this. Another method is you can stop here. So you will get these two products. Okay, what next?
Next, let me see.
No, this one.
3.27. It's saying give the structure of an alcohol that could be used to prepare.
No, B part.
B.
3.24. No. We are doing with 3.25. We did. Okay.
Yep.
Okay. What next we have to do?
3.27.
27. Okay. Give the structure of an alcohol that could be used to prepare each of the following compound. Okay. First of all, tell me what is this compound? A. Aldehyde, ketone, alcohol, or something else. A phenol. What is that compound?
It's a ketone.
It's a ketone. Very good. First, whenever you are doing something like this, ask what you have to make.
Okay.
And because this is ketone, so I know that I can get the, sorry, this is a cyclohexene ring. I can get it from the
secondary
alcohol. So I know that in order to get that one, because this is double bond, I need similar structure for alcohol. It's like called retrosynthesis, going in the back direction. Okay, going like this, back direction. And so I'm going to make this one CH3, cyclohexane ring, and making here OH, because now I know this is secondary alcohol. So this is going to be the alcohol I need. If I oxidize it, I will get ketone, that one. What is the IUPAC name of this compound? This compound. For a ketone, we write the name.
Oh, this one?
Yeah, we remove the E from the alkane name and put ONE.
Okay. 2-methyl
Mm-hmm.
cyclohexanone.
Hexanone. Just remove E and put ONE. Hexanone, you're right. So this is the alcohol you need. What about the next one?
The next one. Let me see. So
what
B,
is the next one is?
B. All right. So B looks like it's what is that? That looks like it's carb. No.
What is this?
It's not. Is it? It's an aldehyde.
It's aldehyde, because you have a carbonyl group like C double bond O, but that carbon also has hydrogen.
Hydrogen. Okay.
So if you see like double bond carbon and hydrogen, at least one hydrogen is there, it means this group is aldehyde.
So this one, if I were to name it, it would be cyclopentane, and that's ANAL.
Yes, remove the E and put AL.
Okay.
Cyclopentanol.
Okay.
So what alcohol you need?
We would need, for an aldehyde, we would need a primary, right? But
primary alcohol. So can you make the structure of that primary alcohol to make this compound?
Yeah, I'm just trying to think here. Let me see. If it were primary.
Make that carbon which has O and H a primary carbon and then attach OH there.
No, that's not it. No, let me see. I'm trying to think if there was a OH right here. That's not it, right?
That's it, because now you are putting CH2 here. This is CH2, am I right? That's it.
That's it.
Yes. You will put like CH2 right like this. So it's make clear.
Okay.
Because this is CH2, of course.
Yep.
And that will give you the product which is shown there. Because it's a primary alcohol. Because the OH is attached with that carbon which has 2 hydrogen.
Excellent.
Right?
Yes. Yes, sir.
Okay, so we already got. What about the C?
C. Okay. 1, 2, 3. All right. So C. So I'm looking at what it is. It's.
Like I will give you some hints.
This is carboxylic acid.
Aldehyde.
Right?
Aldehyde is going to change into carboxylic acid. Alcohol can change into aldehyde. Aldehyde can go to carboxylic acid.
So these are.
But ketone do not go to the, carboxylic acid.
All right. So this primary alcohols go to aldehyde and then to carboxylic acid.
That's right. So you need primary alcohol there.
Okay.
Because if it is secondary, it's going to stop at ketone. You will not get carboxylic acid.
So if that's the case, let me see if I'm understanding this right. That's that. That's this, and then
Look here. How many double oxygen has how many bond?
double.
Double
Oxygen
bond.
is a double.
Also here has double bond.
Yep.
Get rid of this oxygen and put two hydrogen. By replacing two bonds with oxygen, put two hydrogen with carbon. That's it. Look, you have this compound, am I right? In the C part, you're right. CH3, CH, CH3, and this is C double bond O, OH. What I'm going to do is, I'm going to get rid of this and add two hydrogen here. And add two hydrogen.
Okay.
So the structure is going to be and look, it is a primary alcohol. Am I right? If you oxidize this, it will change into aldehyde and finally it will go to the carboxylic acid. Yeah, you're right. That's also right.
No, well, this I was wrong because I put.
Yeah, put another carbon.
Yeah, I put an additional carbon by accident.
Yes, that's why wrong. Otherwise,
And it should just be straight up like that, right?
straight, yeah, direct.
Okay.
Yes.
Okay, so it was carboxylic acid, and we removed the
Double
oxygen
bonded oxygen and put two hydrogen there.
and put two hydrogen. Okay, and this OH stayed there.
Hmm.
Okay. Okay.
And asking this one. Let me ask this. CH3, you have to prepare this thing. Sorry, this is double bond. Sorry, hold on. Hold on just 1 minute. Double bond oxygen and CH3. What alcohol will give you this? Just get rid of this and put two hydrogen. No, sorry, in this case, not two hydrogen. Because this is a ketone, am I right?
Ketone, right.
So in this case, what you will do like this. Just break the double bond, put one hydrogen with the oxygen and one hydrogen with the carbon.
Okay.
And you will get secondary alcohol. Clear?
Got it. Okay. So the ketone, we could break the double bond and add a hydrogen basically to the two things that were involved.
Two things, yes.
Okay.
Okay, what next question?
Okay, we had 3.29. What
3.29, okay.
result from the following processes?
What products would result from the following processes? Write an equation for each reaction. Now you have to write the equation, okay? So let's go here, 3.29.
It's saying 1 butanol is heated, so it looks like an ether.
1 butanol is heated to 140 degrees Celsius in the presence of sulfuric acid. It's like a dehydration. So 1 butanol, first we are making 1 butanol, OH, CH2, 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 CH3. This is 1 butanol or not?
Yes, I agree. It is.
Okay, and now sulfuric acid and 140 degrees Celsius. We know it is dehydration, and because there is no choice, definitely OH you have to remove, and hydrogen is going to be removed from the adjacent. So what you will get?
So adjacent.
Yes. So what you will get? What product?
It would be an ether, right?
No, not ether.
No.
Because you are removing OH and H, water. So definitely when you are removing something like this, you are removing one hydrogen from here. So what you will get? Because look here in this case, this carbon has only two hydrogen and two hydrogen. This carbon has only one hydrogen, three bonds. This carbon has three bonds. They both needs one extra bond. So what I have to do to make four bonds?
Is there going to be a double bond right here?
Double bond. That's alkene. Dehydration of alcohol will give you alkene. And in this case, you will get one butene. Is it clear?
Oh, okay.
Now I'm asking another one. CH3CH. Suppose I am giving you 2 butanol instead of 1 butanol and the same reagents. What you will get? Major product I'm asking.
I think like so 140 degrees. So
I need the major product. And keep in mind, you're right. Don't fight with someone when too many friends are there. Okay?
But Joffrey,
Yeah.
I'm gonna. So it's saying.
Yes, you're right. 2 butene because major, you have to remove the hydrogen from that carbon which has less hydrogen. 2 and here 3. Is clear?
Yeah, like I was just looking at the book. The book has a reaction map, and it says for when an alcohol with H2SO4 is undergoing dehydration, it says that if the temperature is at 140 degrees Celsius, it'll be ether, and then if it's 180,
Oh,
then
sorry.
it will
Okay,
be
sorry.
alkene.
It's a temperature is 140 degrees Celsius.
Mm-hmm.
So what they're saying? Ether.
Ether. Yeah. It says. I'm trying to find the page.
Oh, look the answer of this one because it's a 1 butanol. How it's going to make ether? Okay. Now let me explain this. Okay. Let me explain.
Even. Oh wait.
Maybe the temperature. Okay, no. I'm going to explain this thing. Okay, hold on. Let me explain this thing. CH2. Temperature difference is going to be there. Okay, that's good.
Wait.
CH2 and OH. Okay. Another molecule is also. You're right. This is going to be OH is here. So when the temperature is further higher, that's right. And in that case, two molecule and molecule of alcohol are going to react with each other, and the dehydration is going to be one OH and one H is going to be gone here, like this. And the two units are going to join together. So the product is going to be 1, 2, 3, 4 O, and it's going to be dibutyl ether.
Yes, that's for 3.29A.
Yeah, that's because of the temperature. I didn't pay attention on temperature.
And water.
Yes, and plus water. Yes. So that's in that case you will get that one. That one molecule will lose OH, the other will lose hydrogen, and both going to join through the oxygen. So this is a dibutyl ether. That's the product?
Yeah. For 29A, it says 1 butanol is heated to 140 degrees Celsius in the presence of sulfuric acid, and the product is dibutyl ether, and water.
Okay, okay. You're right. Depending on temperature, because I didn't pay attention on the temperature, it can go like this one.
Oh, for
But it is still it is the dehydration.
the reaction that
But if it is suppose not that temperature, normal temp, like in that case, what alcohol you will get in the first one, second one here. Suppose we will get alkene in this case.
this is 2
So
butanol,
this
right?
carbon has 3 hydrogen, this carbon has 2 hydrogen. So definitely double bond will come here. Am I right?
Right.
Yes, you're right. What next?
I have to make sure that I note because I just noticed in the solution for A, they wrote it as this.
What
So
they have written, just tell me.
they wrote like 2 moles of CH2,
Hmm.
CH2.
Yes.
Because I noticed how you drew two.
Yeah, the same
structure.
thing too, but I put separately like
Yep.
to show you what happening.
Yeah, I gotta make sure I'm gonna put a little note on this type of question because I have to
So
make
like
sure.
two molecules are going to
Yep.
react together.
Yep.
And dehydration takes place not with one molecule, but you can say with two molecules.
Okay.
One is going to lose OH, the other is going to lose H, and they combine through the oxygen.
Okay. Excuse me. Yep. All right. So B says 1 butanol is subjected to an excess of oxidizing agent.
Excess means like it's not going to stop at aldehyde. First of all, 1 butanol is primary or secondary or tertiary? Can you make that 1 butanol?
Mm-hmm.
We already have 1 butanol here, so don't worry about it.
Yep. Primary, right?
This is a primary. So primary can go to the aldehyde and further go to the
Carboxylic acid.
so because they are already saying excess oxidizing agent.
Mm-hmm.
So what you will get?
Carboxylic acid.
Carbox. So you will get butanoic acid. Can you write the structure of the butanoic acid?
Okay. I'm gonna try. Let's see. So.
Okay, one important thing. When you are making this structure, that's I will recommend you to make like this, showing if it is sometimes it's not possible.
Like this.
Like yes, you're right, like this.
Okay.
Okay, through oxygen. Okay, what next? What next? 1 butanol again. It is primary.
Or it's C, right? Is 2
No,
pentanol.
sorry, C. 2 pentanol is primary, secondary, tertiary. To controlled oxidation. First of all, it doesn't matter if you do the controlled or uncontrolled.
It'd be secondary, right? And it's gonna go to a ketone.
Yeah, it doesn't matter controlled or uncontrolled. You will get ketone. So you will get 2-pentanone. What you will get?
2-pentanone.
Yes,
and water.
because the OH is going to change double bond O.
Okay.
What about the C? E.
D or E?
Oh, we did C, so D.
2-pentanol is heated to 180 degrees Celsius in the presence of sulfuric
It
acid.
looks like same type things like 140 degree lux.
Alkene.
Not alkene, it looks like, because I don't remember the temperatures, I don't have the map right now. But under that temperature, it looks like it's going to be ether, I think. Just double check the answer. First, is it ether or not? So I can make that thing for you.
It says for D, the product is 2-pentene and water.
2-pentene and water. So it means they are using the dehydration of one molecule.
Mm-hmm.
So these 2-pentanol, am I right?
2-pentanol is heated to 180 degrees in the presence of sulfuric acid.
Just remember the temperature of ether only, okay?
Ether is
No,
140.
yeah, because that's the main thing. You have to memorize those things, okay? Otherwise, generally they gives uh, alkenes.
Okay.
So in this case, where you will get double bond,
All right.
you
Let's
have to
see.
remove the hydrogen from here or here as a major product for major. That's right. So you will get 2-pentene. Is the answer is 2-pentene?
Yes, 2-pentene. Yep.
Okay.
Water. Yep.
What about the E? Yes, E.
This is the last one for this 29. So it says 2-methyl 2-pentanol is subjected to controlled oxidation. Okay.
2-methyl 2-pentanol, because this is a tertiary alcohol. Tertiary alcohol
No
is
reaction.
do not reaction because do not oxidize. So it's going to tertiary alcohol, only the primary and secondary oxidize.
Got it.
What is the answer? Is the same?
Yep. No reaction.
Because this is tertiary.
You got it. Yes, that's
What
key.
next?
Being able to identify what it is. Okay.
Yes. Okay. What next?
They had 3.31.
3.31.
Says each of the following conversions requires more than one step, and some reactions studied in previous chapters may be needed. Show the reagents you would use and draw structural.
Okay. Each of the following conversion requires more than one step, and some reactions studied in previous chapters may be. Show the. Hold on, just one.
Mm-hmm.
Okay. Just 1 minute. Okay, now let's see. Yeah. 31, you are saying.
Yes.
But where is the.
So it's going from an alkene to a ether,
Okay. Show
or
the
alkene to
31.
ether.
Hold on, just 1 minute. Okay, the A part is what? Alkene to ether. Okay, you already know that one. First, you have to add water and make alcohol. Okay, and then use 140-degree, something like that temperature. CH2. I'm doing like 3.31A. Double bond CH2 alkene. I am going to add water in the presence of sulfuric acid. What I will get? Alcohol. I am doing the hydration. And I will get CH3CH2OH. Am I right?
Yes. Yep.
Alcohol. Now what I'm doing, I'm again heating with sulfuric acid at 140 degrees Celsius. And now 2 molecules of this.
2 of them, yeah.
Is going to join together through oxygen. And you will get diethyl ether.
Yep.
This one, okay. So first is hydration, second is dehydration, but at 140 degrees Celsius. Okay.
Got it.
So it's a 2-step reaction.
Got it.
Next is what?
Next is B.
Pentene, and you want pentanone.
Pentanon. Okay.
So, okay, no problem. This is again what you have to do. You tell me now this one, because you know that we did this one, preparation of ketone, aldehyde, carboxylic acid through alcohols. Am I right? So first you have to think how I can make this alcohol, this alkene into alcohol.
We would hydrate it, right? H2O.
Hydrate, adding water in the presence of sulfuric acid. Sometimes they also use HgSO4 depending together both of them. And you will get this product alcohol. OH. And now you, in the next step, you want to oxidize it. Because it's a secondary alcohol, doesn't matter which oxidation method I use.
Yep.
Potassium dichromate or PCC, it doesn't matter in this case. And H2SO4. And I will get ketone, which is pentanone. This one, two-step reactions. Because you have learned that making aldehyde ketone through alcohols. So you have to think how I can make alcohol from alkenes. You already have learned hydration of alkenes in the previous chapters.
Right, yeah.
Use that one, make alcohol, and then go like that. Now, what about C, you tell me.
All right, so they're going, the reactant that they're showing is propanol, right?
One propanol.
One propanol.
And what you have to make now?
And I have to make, let's see.
You have to make two propanol, am I right?
Two propanol, okay.
Now, this one I want you to think a little bit. It's not difficult.
And that's a secondary, the product is a secondary
alcohol.
Okay.
Yes, so you are making from primary alcohol to secondary alcohol.
Okay. So primary can give us an aldehyde but let's see. Just a second. If I dehydrate this, take a water out, it'll give me a.
Okay, you are moving in the right direction. Do the dehydration of reactant. Okay. And tell me here. I will make this one. And you tell me what you will get. Dehydration means sulfuric acid, HgSO4. What you will get in heat. What you will get in heat.
Should be CH3 bond CH double bond CH2, right?
Yeah, right. And now add water.
Okay.
First you are removing water, now add water.
Yeah, I was thinking, is that right? Okay, so then I'm adding a water.
In the presence of H2SO4.
Okay. So that means that the hydrogen would go to the one who has more
hydrogen. What rule is that one?
Markovnikov's rule.
Markovnikov's rule, that's
okay.
right.
So that means that the product of that one would look like CH3 bond, let's see.
The major product is going to be this. That's correct.
Okay. And then, let me think. So, that's it.
That's it. You got that one.
Wow.
So look, you are converting primary to tertiary. Primary alcohol to secondary alcohol. It's clear?
Wow. Yeah, it's crazy how, I was like, man, I'm not going to just go right back.
This is just practice. Just keep practicing, doing all those things.
Yep.
And then you can do it easily. Now, what about we did A, we did B, we did C. Now D.
All right, D. We have 1, 2, 3, 4, 1 butanol, and it's going to 1, 2, 3, 4. It looks like 2 chloro butane.
But remember, you are not putting the Cl on the first carbon. That's also tricky.
What do you mean?
It's like in the beginning, in the reactant, where is the OH? At 1 position, am I right? 1 butanol.
Yep.
And you want 2 chloro. It means the chlorine is going to the second position. So you can say similar, a little bit similar to the previous problem,
Okay.
but not exactly same, but similar, I can say.
Okay, so if we dehydrate it and then we chlorinate it, would that work?
You're right.
Would that work though?
Yeah, that's right. First do the dehydration.
Okay.
Make alkene, okay?
All right, so we dehydrate it and then we're going to get CH3.
Mm.
Oh no, we're going to use HCl when we do it, right? Are we going to
Yeah,
add?
just use whatever the reagent your book is using.
Mm-hmm. Because I was thinking if I chlorinate it, that means that there's Cl2, but there's only one
No, no,
Cl.
no, 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 not Cl.
Okay, it's going to be
You are
HCl.
adding HbHCl.
HCl.
Not,
Okay. All right, so CH3,
that's called hydrohalogenation.
hydrohalogenation, right, that
Mhm.
one. All right, so CH3, CH2, and when I dehydrate it, I'm pulling one from there. Okay, so that's going to become CH, just CH, right? And then double bond, and then CH2. Okay.
That's right.
And then
And now what you have to do?
we're going to add HCl.
That's right. And again, it's going to follow the Markovnikov's rule.
Markovnikov, good old Markovnikov. And that means that the hydrogen is going to go to this one.
No, no, no. Hydrogen will go where he has more friends.
I forgot the rich. Yeah.
Yeah.
More friends. More friends. It's going there. The Cl is going to go here. Okay. And that's how we're going to end up with this.
Yes, you're right. So it's clear? Okay, we did.
Yep, I have
What-
to. Yep, I just got to do more practice, and I'll be getting there for
Okay.
sure. Yeah, we did quite a few of them. It looks like what there is left. There's 3.3943, so there's 4 total left.
Mm.
We
So you
could-
want to do it when you want to do.
Yeah, we could do. Let's see. Because after this, after we end, I'm gonna start going. I'm gonna start doing more practice on chapter 2. I'm gonna finish all
Okay.
those. And let's see. Would you? I gotta check and see how many hours you and I have worked to see if I gotta send you payment, and I gotta see how many like hours that you and I have used.
Okay.
Let's see. But I'm definitely available. I could do. Heck. What are you up to tomorrow? You busy?
Tomorrow? No, I'm not busy.
Tomorrow
We
night?
can, we can do it tomorrow.
Okay.
And after doing all these 3 chapter 1, 2, 3,
Mm-hmm.
then I want like to do like one session before your test,
Yeah.
1 or 2 sessions. So I will make those questions, some of them directly from here, some maybe I will make it and you will do it according to that one, okay?
Okay.
The quiz type things we will do.
All right. That sounds good. I'm gonna go back. I gotta check my PayPal. I'll check and see the date, and then I'll be able to go to Skype and I'll. Be
Okay,
able to
take your
backtrack
time.
it.
Don't worry about it.
All
Okay.
right. And I want to make sure I get your payment, and
You can pay later also. Don't worry about it. We can do it tomorrow.
okay. All right. So we'll do a session tomorrow. Do you think the same time would work good?
Same time I think is good.
Okay.
Okay.
All right. That works perfect. Thank you so much, Joffrey. This
You're
was,
welcome.
was
Take
a
care.
very
Bye.
good session. Have a good night. Take care.
Good night.
Good night.